This meeting is being recorded.
Problem 25 from Chapter 2 asks us to draw resonance structures for the following compounds here. So I have A through D listed, and I've also given the pattern that we should identify that allows us to draw these resonance structures. So in structure A here, we see a pi bond between two atoms of differing electronegativity. So that's the oxygen and the carbon from the carbonyl. So what we should notice is that the electrons in the pi bond move to the oxygen here, and then we have this structure in the middle. So then we should notice that there is an allylic carbocation. So we have these pi electrons over here that can be moved over. So then what that does is we move the double bond and we create a +1 formal charge on this carbon over here. So for structure B, we have to start an allylic carbocation. So we have this pi bond here that can move over so that +1 formal charge is shifted and a carbocation is now in the middle of this structure. And what can happen is we created an allylic carbocation on the other side here, so we can move these pi electrons in, and now the formal charge has been moved to this carbon over here. Now structure C has an allylic lone pair to start, so that lone pair has been drawn, and that can be moved over here. But at the same time, this pi bond is being shifted over here. So we have creation of a new double bond here, and then movement of those pi electrons to form a lone pair on this carbon here, and then you see that -1 formal charge. So our last structure, D, has 3 resonance structures. So first we notice our pi bond that's between two atoms of different electronegativity. So what happens is we have a shift of electrons from the pi bond up onto the oxygen. Then we have in our second resonance structure here a lone pair that is adjacent to a carbocation. So this lone pair gets moved here. We form a new double bond. Now this oxygen down here has a +1 formal charge, and this oxygen up top has that -1 formal charge like we saw before. But the positive charge on the middle structure was on the carbon. So we had, again, that lone pair adjacent to that carbocation to generate this third resonance structure.